Hello, this is Mrs. Scarple, and in this video we're going to take a look at some angle pair relationships that we can encounter. The first is complementary angles. Complementary angles are two positive angles whose measurements have a sum, which means you add, of 90 degrees. So I have two examples here. We have two angles that share a side. In fact, they're within a right angle as indicated by this box. So they must be complementary because this is a right angle, which is 90 degrees. But they can also be two separate angles. So we have angle A here, which is 20 degrees, and angle B is 70 degrees. And if we add them together, we have 90 degrees. The other type of angle are supplementary angles. So again, it's two positive angles whose measurements have a sum of 180. So you see here we have angle 3 and we have angle 4 that are along this line, and the angle is 180 degrees. Anytime you have two angles sitting on a line, they will add up to 180 degrees. But just like complementary angles, supplementary angles don't have to share any sides. They also do not have to be on a line. So we have angle C and we have angle D, and if we add 115 degrees to 65 degrees, they will equal 180 degrees. And adjacent angles. So we saw some examples of adjacent angles on the previous slide. They share a vertex, that's the point of the angles. So even angle 7 and angle 8 here have points on them. That's called the vertex. So they share a vertex, they share that point, and they share a side. They don't have any points inside that are going to be the same, so they don't overlap, so to speak. They're going to be right next to each other. So if you think about what the word adjacent means, if I said that the park is adjacent to the school, what I'm saying is that the park is next to the school. They're going to be side by side. So we're going to take a look at some angle pair relationships, complementary, supplementary, and adjacent, and we're going to name them, and we're going to give a reason why. So complementary are defined as two angles that add up to 90 degrees. As I look at these angles, I don't see any right angle markings. So then it's a matter of finding which ones add up to 90 degrees. You might want to say that it's 28 plus 72, but if I add 28 to 72, I'm actually going to get more than 90. I'm going to get 100. So it's not going to be the 28 and 72, but rather the 28 and 62. So I'm going to fill in my reasoning first, that 28 plus 62 equals 90 degrees. Now that 28 degree angle isn't sharing anything with any other angle, so I can name that angle as angle B. So we have that angle notation, and then we have the vertex. The 62 degree angle, however, does share a side and it shares a vertex. So in this case, we need to use 3 points to name it. And you want to list the points in the order that you could trace the sides of the angles. The vertex, the point of the angle, is always the middle letter. So it's going to be angle GEF, or you could name it angle FEG. Either way is correct. Supplementary angles are defined as having a total of 180 degrees. But we don't have any angles that are sitting on a line, so that means we need to find two angles that add up to 180 degrees. Well, we have this 108 degree angle and 72. Well, I know that 72 plus 8 is going to be 80, and I still have the 100, so that's going to be my 180. So I'm going to write that because 108 degrees plus 72 degrees equals 180, So that 108-degree angle, that's adjacent to the 62-degree angle, so I need to use 3 points to name it. I'm going to use DEG, so angle DEG, and the 72-degree angle isn't sharing anything, so I can just name that as angle J. And adjacent angles share a side and a vertex. We've talked about that with these two angles, the 108 and the 62. So we can say that angle DEG and angle GEF are adjacent. You'll notice that in the names of those two angles, they share 2 points, and the third point is different. Let's take a look at this diagram. Again, complementary, we want it to equal 90 degrees. Well, that definitely takes out the 131 degrees. So we have 41 plus 49 does in fact equal 90. The 41-degree angle is sharing a side. It also shares a vertex, so we need to use 3 points to name it. I'm going to name it FGK. And the 49-degree angle isn't sharing a point. It's sharing a side with this 131-degree angle, but it's not sharing a point. So I can name that as angle K. Supplementary needs to add up to 180. So it's probably a fair assumption that the 131 is going to be part of that pair. If I add 41 to 31, that's only 72. If I add 49 to 31, that is 80. So it's going to be the 131 and the 49 again. The 131-degree angle is adjacent to another angle, so we have to use 3 points. I'm going to use HGK, so angle HGK, and then again we're using angle K. The adjacent angles are the ones that we had to use 3 points to name. So we're going to have angle FGK and angle HGK. They are side by side. They share the point G, that's the vertex, and they share the side GK. Here you're told that angle 5 is a complement of angle 3, so that should get you thinking, okay, I need 90 degrees. You're given that the measure of angle 3 is 53 degrees. Find the measure of angle 5. So if we know that the two angles have to add up to 90, we can take the 90, subtract the value of angle 3, that's 53, and we will have our answer, which is 37 degrees. For the measure, that's what the M in front of the angle name stands for, so the measure of angle 5. Angle 4 is a supplement. That should trigger that it's going to be 180 degrees, excuse me. And I'm going to pause just a second. What helps me remember which one is 90 and which one is 180, I think about alphabetically, complement comes before supplement, and numerically 90 comes before 180. So you may find that helps. Remember that complementary goes with 90 and supplementary goes with 180. So angle 4 is a supplement of angle 2, and the measure of angle 4 is 29 degrees. Well, if I know the sum is 180, then if I subtract 29 from 180, I'll get the measure of angle 2, which will be 151 degrees. We're back to complements with example C. 1 is a complement of angle 2, so we're thinking 90 degrees. This should say measure of angle 2 equals 5 degrees. Find the measure of angle 1, so that's 90 minus 5, equals 85 degrees for the measure of angle 1. I'm going to go back and clarify that this 151 was the measure of angle 2. And lastly, we have angle 3 is a supplement of angle 4, so we're talking 180 degrees. Take 180 minus 148, and we have 32 degrees for the measure of angle 4. Some other angle relationships that we have linear pairs, so that's when you have adjacent angles on a line. So angle 1 and angle 2 are defined as being a linear pair. Their sides that aren't shared are what are called opposite rays. They're going in the exact opposite direction. Another thing about a linear pair is they add up to 180 degrees, which we talked about earlier when I showed that one pair of supplementary angles. We also have vertical angles. So if you have two lines that are intersecting, you create two pairs of vertical angles. Vertical angles are those angles that you find directly across from one another at the vertex. So they share a vertex, but they're on opposite sides of that vertex. So angle 4 and angle 5 are vertical angles. Angle 3 and angle 6 are vertical angles. So we're going to name all of the angle pairs that we have in these pictures. Remember, linear pairs are along a line. So I could start with, well, angle 4 and angle 3 are along this line. So are 8 and 7. So angle 8 and angle 7. Angle 1 and angle 2 are on the underside of that line. Angle 5 and angle 6 are also on the underside of that line. But those aren't the only linear pairs. I have angle 1 and angle 4 along a line. Angle 2 and angle 3 on the other side of the same line. We have angle 5 and angle 8 along a line. And we have angles 6 and angle 7 along a line. We don't have as many vertical pairs. Remember, vertical pairs are opposite of each other at the vertex. So angle 4 and angle 2 would be vertical angles. Angle 1 and angle 3 would be vertical angles. Angle 5 and angle 7 are vertical angles. Angle 8 and angle 6 are vertical angles. Let's take a look at the diagram at the bottom. Linear pairs, we need two angles that are along a line. Well, I only see two lines. This other shape or this other object that has an arrow on it doesn't continue in the other direction. This is called a ray. And when we're naming linear pairs, we want them to be along a line, two angles along a line. So angle 1 and angle 4 is one linear pair, but angle 4 is also a linear pair with angle 5. Vertical angles are formed by two intersecting lines. So angle 1 and angle 5 are the only vertical angles in this diagram. Angle 2 is not vertical to angle 4 because we don't have that line that continues, and neither is angle 3. I just wanted to double check. Oh, I forgot to mention earlier that vertical angles are congruent. What that means is they have the same measure. So when we look at that second diagram on this slide, I can see that angle 2 is not open as far as angle 4 does, nor does number 3. So that's another reason they can't be vertical angles. So here we go. Two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. So I would recommend you draw a picture because they're on a line. Because it's a linear pair, they're on a line. We can draw a line. We can draw a ray coming out of that line showing that one angle is larger than the other. So if I call the smaller angle x, and I know that one is 5 times larger, that means my larger angle is going to be 5x. And because these two angles are on a line, I know that if I add them together, they will equal 180 degrees because linear pairs are supplementary. So now we can simplify. 5x plus x is 6x equals 180 degrees. Divide both sides by 6, and we have that the smaller angle is going to be 30 degrees. So the larger angle, which is 5x, will be 5 times 30, which is 150 degrees. And last but not least, we have two angles form a complementary pair of angles. The measure of one angle is twice the measure of its complement. Find the measure of each angle. Well, we know complementary add up to 90. So if you wanted to start with a 90-degree angle and then draw a ray that would show that one angle is smaller than the other, we can again call the smaller angle x. Twice the complement would be 2 times x. And we know that they have to add up to 90. So we have 2x plus x equals 90. 2x plus x is 3x. Divide both sides by 3. And we know the smaller angle is 60 degrees. Or not 60, excuse me. 90 divided by 3 is 30 degrees. To find the larger angle, which is 2x, we're going to take 2 times 30, and that is 60 degrees for the larger angle. So this concludes our lesson on different types of angle pairs.